Hi students, welcome to the session on time shifting and time reversal of discrete time signals. Right, so we have the same operations in continuous time signals. Here also we have the operation. Let us see all the things. So first operation we are going to see is time shifting. Right, so if x of n is my given signal, then time shifting is represented by x of n minus k, right? So this is what time shifted version of x of n, right? So depending upon k value, the signal may be shifted right or left. So depending on k, right? So the signal may go right side or left side. Okay. So if k is positive, x of n will be shifted right. Right? X of n will go to right side. If k is negative, x of n will go to left side. Let us see why, how, and all. Right? Okay. So let us take this equation. As I take this signal x of n, let us assume it is 0. N is equal to 0. This is what my x of n. This is 1. N is equal to 1, 2. N is equal to 2 minus 1, right? So let us assume this is our signal. I want to find x of n minus 1. X of n minus 1. Okay. So you see, I will first tell the shortcut, then I will explain the reason behind that. You make it n minus 1 is equal to 0, then it indicates n is equal to plus 1. So what is the thing? You have to add n value to add this n value to the every sample value, so time instant value. So what will happen? 0 becomes 1, so this one will come to 1, this one will come to 2, this one will come to 3, right? That means for every n here n is equal to 0, 1, 2. So if you add plus 1 here, it will come to 1, right? If you add 1 here, it will come to 2. So 2. If you add 1 here, 2 will come to 3. So at 3 it will become minus 1. This is what x of n minus 1. So I told in x of n minus k, here k is positive number, plus 1. So it shifted right. Compared to this one, it is from 0 to 2, it has shifted, and it goes from n is equal to 1 to 3. So it has shifted right. Yes or no? N here goes to 0 to 2, here n goes to 1, 2, 3. Fine. So this is what simple shifting. Are you understanding the point? Okay. Now the question is, why it has gone right? Why did I added and we got the answer, that is right, but we will give one more idea, right? So you compare x of n and x of n minus 1. Right? Here when n 0, it will be x of 0. Yes or no? When n 0, it will be x of minus 1. Right? So we don't have a x of minus 1, right? We don't have that. We don't have x of minus 1 value. Right? When it will become 0 here, when I can get 0 here? Here when n is equal to 1, it will become x of 0. So whatever available here at n is equal to 0, that is available here at n is equal to 1 only. So here n is equal to 0, what is available? 1 available. The same thing available here at n is equal to 1. That's what this one. Okay, let us see when n is equal to 1, what will happen? It will become x of 1. When here we will get x of 1 only when n is equal to 2. So whatever available here at n is equal to 1, the same thing available here at n is equal to 2. So here we have at n is equal to 1 we have 2. The same, this sample will be available here at n is equal to 2. That's what it has shifted right hand side. So hereafter you don't need to do like this. Directly you can do the shortcut method and write the answer. Simply x of n minus indicates it will give right hand side shift, right? So next, let us take the same signal. Let us see what is the signal. This is the same signal we will see. I want to draw x of n plus 1. X of n plus 1. So what is the thing? I told n plus 1 is equal to 0. So n is equal to minus 1. For every n you add minus 1. So 0 minus 1, it will go to minus 1. So this will be available at minus 1. It will come here, right? Here add 1 minus 1, 0. So this n is equal to 1. For that I have to add minus 1. So 1 minus 1, 0. It will go to 0. 2. Next, it is 1. It is 2. N is equal to minus 1. We have to add 2 minus 1, 1. So this will come to 1. So it will be minus 1. Right? So this is what x of n plus 1. Here you see compared to my signal, right? Compared to this one, it started from 0 to 2. This one started from minus 1, 0, 1. Minus 1 to 1. That is, it is starting from 1 to 3. So compared to this one moved to plus 1 right hand side. So it is right hand side shift. Here it is 0. Here it is going to minus 1. So one shift to left hand side. So n plus will shift the signal to the left side by, if it is k unit left hand side. So what is the conclusion we are making here? X of n minus k is a shifted version of x of n, right shifted version of x of n if k is positive. Similarly, x of n plus k is a left shifted version of x of n if k is negative, right? If k is in this here you see in this right. So we have done that, right? X of n minus k, this is the general one, right? So x of n minus k will shift to right hand side for k positive, right? K negative means it will become x of plus k, so it will become left shifted version. That's what we have seen, right? Here what is k value? X of n minus of minus 1. Here k is equal to minus 1, so it has been shifted left hand side. Otherwise you blindly say x of n plus means you have to shift by left side. X of n minus means you have to shift by right side. Okay, so now another point we have to include here is, right, what is the thing? This has started from 0. N minus 1 will start from 1. So for example, this has arrived at 0. My reference should be starting from 0, but n minus 1 start at 1. So instead of starting at 0, it is starting at 1. So it is 1 unit delay. Compared to reference, this is 1 unit delay. X of n is reference. Similarly, my x of n plus 1 is starting at minus 1. So this is, my reference is 0. It has started yearly, right? It is starting at n0. It is starting at minus 1 before n0. So it is advanced. Right? So what is the another conclusion we are making here is x of n minus k, right, is delayed version of x of n if k is positive. Yes or no? So if k is positive, it will be x of n minus 1, right? And sorry, here we have to please change. Here also x of n minus k. K is negative means it will become x of n plus k, so it is positive. Okay, similarly, x of n minus k is advanced version of x of n if k is negative. If k negative means it will become x of n plus k. That's what I mean. X of n plus k. Here it is n k positive means it will be x of n minus k. Right? Now you understand. So hereafter we can draw directly. Suppose if you are given one signal like this, 0, 1, 2, minus 1, what is the thing? 1, 2, 3, 1, 1, 2, minus 1. Suppose if you have to draw x of n minus 1 or 2. Okay, let us see, we have to draw x of n minus 2. N minus 2 means I told it is delay by 2 unit. So it has started at minus 1, 2 unit delay means it is 1 unit delay, this is second unit delay. Minus 1 plus 2, it is plus 1. So it is shifted to here. So it will start from 1 only. At 1, we will have this one. 1. At this will go to 2 because it is shifted by 2 unit. So 0 goes to 2. So at 2, we will have a 2. 1 goes to 3. So it will come here. 2 goes to 4. This is what delayed version, delayed by 2 unit. Suppose if you have to draw x of n plus 2, what you have to do? Everything should be shifted left advanced. So minus 1 should start from minus 3 because 2 need advance. So it will go here. 0 goes to minus 2. Right? 1 goes to minus 1. 2 goes to 0. Right? So this is what you call delay time shifting operation of discrete time signal. Okay, so time scaling I will deal in some other video because it has taken so much of time. So I hope you understand the concept clearly. If you have any doubt, please post your questions in the comment section. Thank you.